Hello, my name is Celeste Rodriguez, and I'd like to give a brief review of projectile motion. Here I provided a Google definition in which where it states that projectile motion is the two-dimensional movement of an object, a projectile, launched into the air, influenced only by the constant downward acceleration of gravity, ignoring air resistance, meaning that air resistance is negligible. It does not have any impact whatsoever. Now, I provided an image here that I think suits well the definition, and it states that the two-dimensional movement you can see is the y-axis and the x-axis, the vertical motion and the horizontal motion, and it shows the projectile of a ball having a parabolic movement. I want to go more in depth of the vocabulary used in the prior definition. What is a projectile? Well, according to the physics textbook, a projectile is an object shot through the air. A projectile's path through space is called its trajectory. Knowing a projectile's initial velocity can help you analyze its motion. As you can see here in figure 1, a projectile is launched horizontally. It immediately curves downward, but in the second figure, it curves upward due to the higher angle. It rises then falls. You're able to see the maximum point being the top of the parabola and how it just fluctuates downward. Here's an image I really like because it shows projectile motion on a graph to the T represented by fundamental concepts. Now, there's a lot to unpack here, but I want to start by looking at the points, the first point being point A. So in point A, an object is launched. We don't know the initial velocity, but we know that it's at an angle of theta. Now, this velocity can be split into two independent components, the horizontal component and the vertical component. The vertical component would be the y-axis, and the horizontal component would be the x-axis. Now, the horizontal component of the velocity remains constant throughout the motion because there is no horizontal acceleration. As you can see, the only force that's acting upon it is little g, which is gravity, and it's only affecting the vertical axis. And if we look at how it moves to point A to B, the object only moves upwards, but gravity is slowing it down, causing this, it shows in a way a decrease in the upward motion. On point C, on the other hand, it reaches its highest point, and if you look at what it provides, it shows that the vertical velocity is 0. But the horizontal velocity is still present. This is very important as it shows that the point of the object does not stop moving, but it only stops moving upward at that certain point, which is point C. And after point C to point D to E, we can see that gravity causes the object to accelerate downward. The vertical velocity increases in the downward direction, while the horizontal velocity remains unchanged because it is constant. Now, just overall, throughout the entire motion, the direction of velocity is always tangent to the curved path. And you can see this is represented in the graph as these lines that point out, the red lines, that's the tangent way. And the combination of the constant horizontal motion and the changing vertical motion produces this parabolic trajectory in which we learned this definition earlier. And to just sum everything up, what can we see in this image is that projectile motion is shown by analyzing horizontal and vertical motion separately, with gravity being the only thing that affects the vertical axis. I hope you understood and enjoyed this video. Thank you so much for watching.